Our lesson now will be equations of lines in space, which means equation of line in 3 dimensions. These are all lessons from vectors, which are parts of calculus and vectors. So let's see exactly the same way in R2 what we say. They're straightforward. We have the types of equations we have seen. First we write, so 3-dimensional means we have x, y, z, x, y, z. So the same way we have the direction vector, we have the point. So this is any point, x, y, z, and we have a point which is the initial point, xo, yo, zo, and the line is always multiple of the direction vector we have. So we have always a direction vector the same way in R2. So if direction vector is, let's say, A, B, C. So if the direction vector is A, B, C, and the point, initial point is, xo, yo, zo, and x, y, z is any point. Therefore, the vector equation which will be xo, x, y, z equal to xo, yo, zo plus t times a, b, c. And symmetric equations are, I isolate the t, x minus xo over a, y minus yo over b, z minus zo over c. The parametric equations x minus xo ta, y minus yo tb, and z equal to zo tc. ABC is always a direction vector. So these are the 3 equations we have for now. Let's see equation number 1. Example number 1. Write a vector equation and parametric equations of the line x minus 4 over negative 3 equal to y over 5 equal to z minus 1 over 6. The first thing we find is, what is the direction vector? The direction vector here is, if they are written in right format, x, y, z. Yes, x, y, z is as a first, at the beginning. Therefore, direction vector is minus 3, 5, 6. The initial point, the point we have is whatever makes the numerator equal to 0, which is 4. I don't have any number after y, so 4, 0, 1. Therefore, vector equation is x, y, z, or I can write r vector only. Initial point is 4, 0, 1 plus t minus 3, 5, 6. Parametric equation will be x equal to 4 plus minus 3t, y equals y equal to 0 plus 5t, z equal to 1 plus 6t. Okay, these are number 2. If I am given find direction vector, find find direction vector. If I have x minus 2 over 4 equal to y plus 5 over 2 equal to z minus 3, this is always over 1. Therefore, direction vector is, the denominator is 4, 2, 1. For the second one, x plus 3 over 5 equal to y minus 1 over 3 equal to 6 minus z over 4. First thing I see is if they are written in the right format. No, this is not 6 minus z. This must be changed to x minus 3 over 5, y minus 1 over 3. Z must be first, so I multiply by negative 1 over negative 1, numerator and denominator. So it becomes z minus 6 over negative 4. Therefore, direction vector is 5, 3, negative 4. So if I am given 3, write symmetric equations. I'm given x, y, z equal to 1, 2, 3 plus t negative 4, 5, 0. Symmetric equation will be x minus 1, the point, over direction vector a equal to y minus 2 over 5, z minus 3 over 0. I cannot have over 0. I cannot have over 0. Therefore, I cannot write this one here. So what I do is x minus 1 over minus 4 equal to y minus 2 over 5. I write comma here and I say z is always 3. We don't use the direction vector because it is 0. I write z equal to 3. If the 0 was under y, I would say y equal to whatever number you have. So that's what we have.